All right, so I think this is recording. Let's take a look here at number 15. It says our f of x and g of x inverses. So we want to verify by finding the function composition of f composed with g and g composed with f. So if both of those are equal to x, then we'll conclude, yes, these are inverse functions of each other. And if they're not equal to x, then we'll conclude, no, they're not. We have different ways that we could determine if two functions are inverses of each other. We could graph each function and see if they are reflections across the line y equals x. We could find the equation of f inverse by switching domain and range and doing it that way. But the directions specifically say to use this function composition, so we have to do it that way, even though we know there's other ways that we could verify it. So if we find this first one, f of g of x, we want to take the function g and plug it into f. So g is this cube root function. And so what will f do to the input? Well, f always creates an addition problem. It takes the input no matter what it is and it cubes it, and then it adds 1. We're giving it this cube root of 1 minus x. And if we cube a cube root, the radical goes away, and I have 1 minus x plus 2, and that simplifies to 2 minus x. So since that's not equal to x, I know that these are not inverses of each other. Now, it does say to find the other. If all it was saying is, are they inverses to each other, we can answer that no. But it says verify by finding both f of g of x and g of f of x. So let's find the other one. But we know to anticipate that it's not going to be x. So this time we're going to take f and plug it into g. So g will take the cube root of 1 minus the input. Now, if I'm with the input, I'm subtracting the whole input, not just the first term, so I need parentheses around this. And so I have the cube root of, if I distribute that, I'll have 1 minus 1. Well, that cancels, but see, this is a negative x cubed. And with cube roots, the domain and range are all real numbers. I don't have to worry about absolute values or worry about taking the cube root of negative numbers, because we can do that. For instance, the cube root of negative 8 is negative 2. So negative x times negative x times negative x is negative x cubed. So if I have the cube root of negative x cubed, this is just negative x. Well, again, that's not equal to x. So it just confirms what we found over here before, that these two functions are not inverses of each other. Now, both of these functions would pass the horizontal line test, and they do, their inverses are functions. They do have an inverse, but they are not inverses of each other, is what we're concluding. Each one definitely has an inverse that is a function, but these are not inverses of each other. All right, well, hope that helps. I'll talk to you later. Bye.